Now let's talk about mole. Let's talk about mole. Mole. Okay? Yeah. Now, from the previous class, we have short review, right? Okay. Now let's take a look. For example, we have 1,000 of yes. We have donuts, yeah. Oh yeah. 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 We have donuts. And our donut. Yeah. So if we have 1,000 of donut, then meaning that we have how many donuts? 12, correct. Yeah.
We're offering you the way of the life.
Soalnya saya mau minta kalian menggambarkan satu mol donat ya. Oke.
Warnanya beda, Pak.
Oh iya, warnanya beda.
Warnanya beda ya, bagus, Pak. Tapi dekorasi Pak, fansnya Pak. Jangan sama, Pak.
So this is my very favorite donut, yeah. When I go to a donut shop, I will only buy this flavor of donut, yeah. So this is the mint flavor of donut, my favorite flavor, yeah. So if this donut has 2 strawberry, yeah, has 2 strawberry in its donut, yeah. As the garnish, I also like strawberry, yeah.
How many strawberry do we have? I have 2 strawberries on each donut. I have a dozen of strawberries. How many strawberries do I have? Oh, donut melon is like
Okay, so this is very special. This is very special for Christmas decoration. So they have the strawberries, yeah. So now, if I ask, yeah, how many dozen of strawberries that I have in this 1,000 of donut?
24.
Yes. So the answer gonna be 2,000 of strawberry, right? So, okay. Now, if we want to talk about the mall is kind of similar to dozen. Yeah? If dozen is only 1,000 is equal to 12 pieces, then the one mole is equal to 6.02 times 10 to the 23 particle.
Gambaran, Pak. Ya, Pak, gambar, Pak. Ayo, Pak. Ayo.
And this, okay, enough. So now, the particles word, yeah, actually refer to can be atoms, can be molecules, and also can be ions. Okay, can be atoms, molecules, and ions. So this is particle. Yeah. Now let me test you. Let me test you. For example, we have 1 mole of H2O molecules. 1 mole of H2O molecules. So this one is H, and this is the O. Okay? Yeah. Now, how many mole of H atom that we have? How many mole of O atoms that we have? How many mole of H2 molecules that we have? And how many mole of O2 molecules that we have? So, firstly, from the H atom, how many H atom that we have? How many mole?
2.
Okay, the answer is 2. Yeah. How many mole of O atoms? 1. How many mole of H2 molecules? How about this one? Now, we go further to the calculation. This is the thing that you have to take note. Yeah. I use the symbol of N to show you the amount of mole. Yeah. So this is the mole. So this is the mole. Yeah. If we're talking in terms of the N, which is N is the number of particles, in terms of the number of particles, then the mole is equal to the number of particles over by Avogadro number, 6.02 times 10 to the 23. Yeah. If now I have in terms of the mass, yeah. Normally we use this for the solid, right? If we have solid substances, we know the mass, and the mole actually is just the mass over by the mR if it is a molecule, or we also can say that it is also the N mass over by the AR if it is atom. Yeah. Again, next. If it is a solution, yeah, if it is a solution, meaning that the mole here that we have is apa ya? The mole that we have is not about the solvent, you know. The mole that we have here is the mole of the solute, right? The N is the mole of the solute. Let's say this is our solute. So meaning that the mole of the solute is equal to, ada sih, concentrations times by the volume. Yeah. So C is the concentration of the solution, and V is the volume of the solution. Yeah. And N here is the mole of the solute. What is the difference between this one and this one? The mass and this concentration thing. Bedanya adalah di substance yang kita punya, ya. If this one we have it as pure substance, can be solid or it can be liquid, ya kan? And the mass that we have is totally or fully the mass of that pure substance. pure compound, right? Well, here actually it's a mixture between the solid and also the solvent. But what we want to know is the mole of the solid, which is the red color, right? So we do it differently. This one is for solution, while this one is for pure substance, right? Pure compound substance. Next, the last. If it is a gas, yeah, normally we see the gas in terms of the volume. Okay, be careful. The volume here and here are not the same. The volume here is the volume of the solution, while the volume here is the volume of the gas. Yeah, ada. So the volume of the gas is very sensitive toward the pressure and temperature. The volume of the gas is really sensitive toward the pressure and the temperature. Yeah. We have so-called RTP. Yeah. If it is RTP, what is RTP? RTP is room temperature pressure, which is 1 atmospheric pressure and 25 degrees Celsius. Yeah. If this is the condition, then the mole of that particular gas is equal to the volume over by 24. Ya, because this is the apa tadi? This one is the molar volume. Molar volume, ya.
Kalau bukan room temperature sama pressure-nya bukan.
Sabar. Ya. Okay, next continue. If it is STP, STP is standard temperature pressure. The word standard refer to 0 degrees Celsius. Yeah. Then the N will be equal to V over by 22.4. Yeah. And beware, the unit that we use for the volume, yeah, the unit that we use, apa? Ini 6 semuanya.
Iya, ini kayak rangkuman.
Jadi mungkin next week aja kita bisa tes kayaknya. Kalau mau.
Semua yang next week test.
Bisa.
Bisa lah. Oh, yang ini aja belum dibagi. Next juga ya sebelum apa sebelum main.
Bisa.
Guru lo aku.
Muridnya aku tapi. Belajar mati.
Okay, M is the mass, yeah. The unit is gram. And our N, yes, N is small and the unit is small. Yeah. V that we use, the unit is decimeter cube. And then what else? Concentration that we have, the unit is mole per decimeter cube. Sometimes you also can call it as molar. Yeah. Okay. Or normally you just write it like this, yeah, mole over the cube decimeter. Okay. Huh? Molar, yes. It's equal to molar, yeah. It's showing you the molarity, yeah. So this is all the formula. But for this gas, actually, how come? How can you get this 24 and 22.4? Huh?
Malah.
Enggak lah.
Jadi dites apa gitu?
You got it from the ideal gas equation. Yeah. In which P times V is equal to N times R times T, where your P is the pressure and the pressure in atmospheric pressure, V is the volume and the volume is in decimeter cube, N is the mole and it's small, right? R is a gas constant, ideal gas constant. Which is equal to 0.082. Yeah. 0.082. What is this? Physics mungkin nggak ada ya. Physics. Temperature. Yeah. Let's say we have the pressure is 1 atmospheric pressure, and the temperature is 20. So we have to convert it to be Kelvin plus 273.15. So it will be 298.15. Yeah. So now let's plug in with the number. TV is equal to nRT. T is 1. V we don't know. N we don't know. This one is 0.082 and the Kelvin is 298.15. So we can rearrange this formula to be N equal to V over by 0.082 times 298.15. Yeah. If we calculate this number, we will come up with the value of 24.4. Yeah, or if you make it to be two significant figure, it will be 24, right?
Yes. Yes, it's good. It's good, yes.
The last question for today. Why we have to use the mole? Yeah, the mole is one measure of the amount of matters, right? The amount of matter or the amount of substances. Ya kan, mol itu cuma hanyalah ukuran yang menunjukkan banyaknya suatu substance kan. Nah kita kan punya mass, we have the mass, right? Why now we have to study about the mole? Why we have to study about the mole? We also have the mass that can tell you the amount of particle. The amount of substance. Right? Huh? Yes. Let's take a look. We have one reaction, yeah. Let's say if we have HCl plus with calcium carbonate, it will form calcium chloride and water. This one balance already, right? So from here I can say that William merasa terganggu ya. William merasa terganggu. Okay. Enough. Now, so let's see about the molecules, yeah? The molecules. How many molecules of HCl here is 2, right? Here is 1, here is 1, here is 1, here is 1, right? How do you know? From this one, though? Coefficient, right? Coefficient telling you about the molecules, right? And we also have this formula N equal to mass over by mR, right? So meaning that if I have 2 moles, now I'm talking about the moles, yeah? if I multiply this by 6.02 times 10 to the 23, right, for all, yeah, I times it with Avogadro number, right? So the number of the mole will be 2, 1 mole, 1 mole, 1 mole, and 1 mole. This one is molecule and this one is moles, yeah? Okay. So if I have 2 moles of this HCl, I know the MR of HCl is 36.5. Then meaning that the mass of HCl that I have for 2 moles is equal to 73 grams.
Kalau misalnya kita itu MR-nya nggak perlu dilihat koefisiennya.
Kenapa?
Kalau itu MR nggak perlu dilihat koefisiennya.
Nggak perlu. Nggak perlu. MR is for one molecule.
Kalau 2 HCl itu MR-nya dari CL.
Enggak.
Masih HCl.
Ini masih 36,5.
Iya, misalnya 3 HCl 4 HCl ya sama.
Sama aja MR.
Tapi masih 36,5.
Because MR is the body mass of a molecule. A molecule. So this one is 73 grams. Yeah. By doing the same way, this one is 1 mole. And the MR of this one is 40, 12, and 3 times 16. So it will be 100. Okay. And also this one for calcium chloride. 1 mole of this, and the MR is 40 plus 35.5 times 2. So it will be 75. Okay. And this one, H2O. 18. And CO2, 12. CO2 is 44. So here what we have is 44 grams. Yeah. So previously from the previous chapter, right? We can generate these reactions in which you can tell, oh, this one is 2, 1, 1, 1, 1, right? So chemical reaction actually the same like cooking. Yeah, you have a certain recipe to make it, right? And the recipe that we have is based on the number of molecules, right? Because the reaction happen between molecules, right? So when you see here, the ratio of the moles and the ratio of the molecule very related to the number of molecules in this equation, chemical equation. Well, the grams, the mass, cannot really tell you.
Itu bukannya 750. No, it's 36.5. Oh, it's I think.
Which one?
I can't see.
Okay. So let's see here the gram, yeah, the ratio of the grammage actually cannot tell you the proportion of the molecule, right? But firstly, what we have is this reaction equation, right? So meaning that we cannot work by using the gram. Why? Because different molecule, different type of compound will have different body mass, right? So meaning that this mass cannot really give you idea how much is this substance, ya kan? Kita nggak tahu 73 grams ini ternyata 2 moles. Tapi kok di sini 100 grams kok 1 mole ya? So this number cannot really tell you how many molecules, how many moles that we have, you know? Because different compound they have different body weight, they have different body mass, correct? They have different MR. So that's why we have to learn about the mole. So later on in the calculation, we're gonna use this moles. We will not use the mass or the volume or other than that.